Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at the paper software engineering. For today's session, we will be talking about software reliability engineering. Reliability in turns means a failure free operation. We have looked at various instances in which we have been talking about errors, bugs, failure, fault, defect and so. But then of the total number, how many different operations have been made failure free is a basic understanding of software reliability. This reliability is needless for a software, it can even be for a hardware, it can be for other operations also. So, we give utmost importance for this software reliability primarily because the user will post us a question, how reliable is this software? That means how long, for a duration, for a cost, for a quality of such a product, how much to invest, how to get to know about the reliability. So, this lecture we will be talking on with the different objectives. Initially, we will try highlighting on the differentiation between failures and faults, over which we will understand how to produce a failure free operation. As a next instance, we will be highlighting on the importance of execution time and calendar time. We will also point out the time interval between failures, which is mean time between failure MTBF and mean time to retrieve. To understand on the user perception of reliability, or what does the customer understand from the reliability, will be the basic discussions. So, we will try initially defining what is software reliability, then we will go on comparison between failures and faults. So, software reliability is defined as the probability of failure free operation, which I was telling you. How many operations of the different number of operations, this software might contain thousands and thousands of operations to be performed. How many of these operations would work well for a longer duration? So, in terms of looking at durability, it will be in terms of duration, in terms of looking at failure free operation, it will be reliability. So, failure free operation of a software system for a specified time. So, 5 years from now, 1 year from now, 2 years from now is the specific time that we are trying to mention in a specific environment. So, I redefine again, software reliability is defined as the probability of failure free operation of a software system for a specified time in a specified environment. So, there are some key elements which are associated with the software reliability, which include probability of failure free operation, length of time and failure free operation, and we are given to work on a constrained environment. So, here after having looked at change management, configuration management, capability maturity model, personal software process, team software process, testing, design and things like that, now that we have come to understand on a software which will be delivered and which is an incremental process also. So, for an incremental process, it is needless that many operations which were executed for the fundamental version all should work for even for higher versions also, that is how it should be designed. So, when I am going for higher versions of the software, how many of the fundamental operations are able to work still for the higher versions of either the browser, or I might have to check for the compatibility rather. So, that is a given environment. So, we will try understanding on the failure intensity, which is a measure of the reliability of software system operating in a given environment. So, if at all we wanted to understand on failure intensity or the intensity level of the failure, so it is primarily dependent on the reliability of the software. For example, in case if I am to work on a air traffic control system, how reliable is the system? Even in case I have a control system associated with every airport, and this airport has to be, or this control system has to be efficient enough, reliable enough, so that all the instructions put forth for the landing plane should be effective. So you may have to appropriately mention a duration. You might know the causes of in case if there is a crash. So reliability is at most important, and we will also parallelly try to understand on the intensity of the failure. Some of the factors which influence the software reliability are a user's perception of the reliability of software, completely dependent on two different categories of information. One is the number of faults present in the software, or the number of failures associated with the software. We will try understanding on the users or the ways in which users operate the system, which is called an operational profile. So every time we develop a software, in turn we also maintain a complete profile for the software, and there will be an associated documentation which mentions the operational profile. So the fault count in a system is influenced by size and complexity of the code, characteristics of the development process used, education, experience and training of development personnel, which again is your PSP process, operational environment. So when you look at all the lectures that we have seen before, everything is interrelated, although it looks like a different topic of interest, but then everything is associated in one form or other. So likewise, when you understand software engineering, HR management is important, personnel management is important, team understanding is important. So many different management subjects comes into perspective of software engineering. So software engineering is not just to make a person to act as a better programmer, rather it would be talking about the various characteristics of the processes, the individual's skill sets and the outside environment. So if at all you are trying to understand on software reliability where these reliable softwares are applicable. So when we go for comparison of software engineering technologies, we will basically try understanding on the cost of adopting to a specific technology. Not only that, there will be appropriate returns from the technology in terms of cost and quality. So any customer who is about to invest for a project, their first preliminary question will be on the cost and quality of the product, and how, or when it comes to a real time implementation, how can this product be adoptable to the real time or the technology that is coming new. So measuring the process of system testing, the failure intensity measure tells us about the present quality of the system. Higher the intensity means more tests are to be performed. When we understand on the intensity of the failure, if the failure seems to be larger in terms of intensity or higher in terms of intensity, that means the product is not reliable. So we need to perform more volume of test cases, more number of tests, starting from compatibility test, all the black box and white box tests, including stress, you have document test, and so where in the document test you would have tested it for how to kind of questionnaires. So if you are a little bit careless on the some of the questionnaires that has been asked on the testing team, then the failure, it is a high probability that the failure intensity might go high. So controlling the system in operation, where the amount of change to a software for maintenance affects its reliability. So in terms of looking at software maintenance, this also we have discussed. Software maintenance in turn affects the reliability. If at all we are not maintaining the software appropriately, then the reliability of the software might increase. There should be a revamp on the system every now and then. So better insight into software development process, like quantification of quality, gives us a better insight into development process. Even for the software reliability, this reliability is to make up with the requirements that we have understood at the earlier cases. As you might know, requirements are classified into functional and non-functional requirements. Although the software reliability is part of non-functional requirement, but then this reliability study is major to focus on functional requirements also. So, system's functional requirement might specify error check, recovery features and system failure protection. So, these are supposed to be the functional requirements, but then your system reliability and availability are specified as non-functional requirements for the system. In case if I am to talk about system reliability rather than specifically talking about software reliability, in case of a system I might have to check for the hardware, software and operator. So, for hardware reliability we check for the probability that a hardware components fail given a execution time or given a time. Software reliability, as we have defined, probability a software component will produce an incorrect output, and these are the characteristics of a software where we have mentioned software does not wear out, but then these softwares applied for various compatibilities or taken over to various versions or taken over to various configurations, how does it perform is the understanding that we get through reliability. So, software can continue to operate even after a bad result, and with regard to the system we have operator reliability where we check for the probability of a system user who makes an error. So, to understand the failure probabilities, these are just a probability of failure free operations. So, to understand on the failure probabilities, if at all we have two independent components which are associated for a system, so then the operation of the system depends purely on two independent systems, one is A and B, probability of failure happening at system A, probability of failure happening at system B makes it to probability of the system. So, if the components are replicated through the probability of failure, then it is to the power of n. That means we are accumulating everything together, so it increases exponentially. So, the functional reliability requirements are, we may have to check all operator inputs to see that they all fail within their required ranges. Not only that, we may have to check for all disks for bad blocks each time it is booted, and the system is implemented using a standard implementation of ADA. Those are with respect to the functional reliability, but as we have mentioned, reliability is a word which talks on the non-functional requirement specification. So, the required level of reliability must be expressed quantitatively, and the reliability need to be dynamic in nature in terms of system attribute. Source code reliability specifications are meaningless. Say for example, for every KLOC, that is kilo lines of code, we get so many faults, so that it cannot mention the system is so reliable. Rather, that is a measure that we tend to adopt during our model creation, during Six Sigma component understanding, but the same cannot be an understanding for software reliability. So, we try to apply appropriate metric to specify the overall system reliability. We also have hardware reliability metrics, like whatever that applies to hardware reliability metrics are not applied for software also. So, software failures are often design failures alone. Often the system is available after the failure has occurred, and if you look for the hardware components, hardware can wear out. So, when you look at hardware and software separately, hardware can wear out and software does not wear out. So, this is to mention on the metrics associated with the software reliability, where it is a unit of measure for a system reliability. System reliability is measured by counting the number of operational failures. So, how many number of failures in terms of P of A plus P of B plus P of C, any number of system that tends to fail and relating to these demands made on the system at the time of failure. Probability of failure on demand, where the probability system will fail when a service request is being made. These are made useful when requests are made on an intermittent or infrequent basis. So, in case if I am not using this software for a longer period in time, what would happen? for that, or what would be the account for reliability. So, appropriate for protection systems, service requests may be rare and consequences can be serious if the services is not been delivered. So, when it has not been used for a longer period in time, there is an appropriate consequence that we may have to face in terms of failure. So, this is a safety critical issue and will be handled purely through exception. Here we are introducing another important factor called the rate of fault occurrence, which is abbreviated or which is given as an acronym of ROCOF, which is something like we tend to reflect the rate of failure in the system. So, rate of fault occurrence is the rate of failure in the system. This is useful when the system has to process a large number of similar requests that are relatively frequent enough. This relevance is not only for operating system, it can also be for a transaction processing system. As I have mentioned, we have two different reliability matrices. One is called probability of failure on demand, which is nothing but for every or 1 in every 1000 requests the service fail per time unit or per unit time. That means 1 out of 1000 requests that has been made by a customer, there seems to be a failure given an unit time. So, POFOD is equal to 0.001, that is 1 divided by 1000, whereas rate of fault occurrence is 2 failures for each operational time. Given a specific operational time, for every 100 operations that we perform, there can be 2 failures. So, we measure ROCOF as 2 divided by 100, which becomes this way. Not only that, apart from the two measures like POFOD and ROCOF, we also have very important measures associated with reliability, which are mean time to failure and mean time to repair. Mean time to failure is defined as the average time between the observed failures. So, we have two different operations that has been performed, or the operation has been performed sequentially, but then I understand on the sequential operation I have a failure which has happened, and after certain point in time of an operation I understand there comes another failure. So, we tend to study the mean time that we tend to take between two different failures. So, if it is quite smaller in number, that means the probability of getting this failures quite often in the system is so high. But then if the failure intensity or the failure happens very rarely between the operations, then the probability of the failure that is happening in this particular system or the reliability of the system is quite high. So, we can understand on reliability purely through mean time between failures. So, the metric associated for reliability study is equated with MTBF by 1 plus MTBF, which gives us the actual reliability between failures, how frequent is the failures happening between the operations. Whereas, when we tend to check for the availability, we not only take mean time between failure, but then we tend to take the mean time to repair automatically or to repair by a team. So, mean time between failure divided by mean time between failure plus mean time to repair. So, availability is measured to be how automatic the system can correct by itself or an attempt done by somebody else to correct this failure. So, that becomes availability, and reliability can also be measured with the same metric. We also have another factor which is called mean time to failure, MTTF, which is a measure between observable system failures, and for certain systems which are very stable, we compute this mean time to failure as 1 by ROCOF. So, these are relevant systems where individual transactions take a longer period of time for it to get processed. So, when it is not for a simple systems where we do a simple processing of coding the system and trying to execute. Even when we go for systems which use CAD as in its applications, when we go for higher sets of applications like this graphic processor, including graphic processor by way of executing a code, then we may have to appropriately calculate all these metrics so that we can understand on the reliability component of the software. So this is one of the objective that we have mentioned, time units. We tend to understand the various time units because calendar time has also been an important component to understand on the failure free operation of a software. So we have raw execution time, which is nothing but a non-stop system. Most of the servers which runs 24/7 cross 365. So those are computed to have a raw execution time, whereas we have a calendar time where we follow a regular usage pattern, and after regular usage patterns there will be an appropriate maintenance which will be associated. Not only that, the system has to look for the number of transactions where whenever demand arises, we may have to project only those type of transactions into its operation. We have looked at this availability as a metric by the use of MTBF and MTTR. So we will try to define this availability. Availability is defined as a measure, the fraction of time system is really available for use. So how long is the system really available for use? If I have mentioned a specific duration for which I can take up a particular task, and this task is runnable or executable only for a certain duration. So any which times an operation is put to a resource and it is made available. So this takes repair and start times into account. So that is also been considered as a task. Repair and restart times are also been considered as a task that is to be performed within the system. So that is called, that is in turn is a part of availability. So relevant for non-stop continuously running systems also. Say for example, we run this traffic signal continuously throughout the year. We also have to, at the same time, we may also have to look at the failure consequences. We understand and study it with various case factors here. Reliability does not take consequences into account. What would be the consequences if at all it has been done? So that kind of a study is not a part of reliability study. If at all we have transient faults which has no real consequence, but other faults might cause data loss or corruption. And this may be worthwhile to identify different classes of failures and use different metrics for each. So when we go for higher advantages of software engineering, then we tend to study all these things. But then if you are about to study on the failure consequences, further it specifies the reliability not only as the number of failures but also as the consequences. So here we do not concentrate on the consequence of failure, but then software reliability purely looks at the failure free operation of the system rather than looking at the consequences. Consequences has been a separate study. So failures with serious consequences are more damaging than whose repair and recovery is straightforward. We have different reliability cases. Specifications may be defined for different failure types. So if you look at the classification of all these failures, so in order to maintain failure free, we may have to classify failures and we may have to study on that, so that we are making every operation failure free. So we have different types of failure classification starting from transient to corrupting the system. In case of transient systems, there will be occurrences of very few or certain inputs only, whereas in case of permanent failure, there will be occurrences of all the inputs. Even if one input fails, then it becomes a permanent failure. The other failure is called recoverable failure, wherein the system can recover without the operator's help. So the system automatically tries to recover it on by itself. The system automatically can update itself or recover itself without any help from the operator. There are unrecoverable failures also which seeks operators help. There are systems which are non-corruptive, which does not corrupt the system or the state or the data, whereas there are systems which are to purely corrupt on the data. So, it becomes system state or data that is to be altered. So, after having done quite a bit of study on the reliability metric, reliability classification, failure classification, it is time to look at the specification that is mandatory for building the reliability. So, for each subsystem we may have to analyze on the consequences of possible system failures. So, for every subsystem that we are about to develop, in case it is the responsibility of the developer, it is the responsibility of the tester to understand the consequences or the impact of the failures that is going to happen. So, that will be made to analyze when I am going for a subsystem design itself. So, for any system failure analysis, partitions failure into appropriate classes. So, for each class send out appropriate reliability metric. If you look at this POFOD, no database corruption, which actually means POFOD class will be less than 1 in 200 million, which is very meager. So, for every 200 million lines of code we can find only very few defects, and you may have to take a point here. We cannot build a system which is 100% reliable, but then we can build up a system which is 99 or 99.99% reliable systems. So, in case of transactions, we take 1 second to verify, and simulation has been carried out for transactions for every 3.5 days. As a summary for this particular session, the discussion was to talk on software reliability, where we have said we need to create failure free operations, and we have also measured mean time between failure, mean time to failure, and so. So, reliability is purely user oriented quality factor relating to the operation of a system, and this session we talked more on the fault and failure, execution and calendar time, time interval between failures as mean time between failure MTBF, failure in periodic intervals, and we also talked about the failure intensity. As the intensity of the failure is more will be or less will be the reliability. Software reliability has been defined in two different ways. One is on the probability of failure free operation of a system for a specified time in a given environment, and we also looked at from the perspective of failure intensity is a measure of reliability. Not only that, we also tried looking at the consequences, what type of impact the software might produce so that it affects the reliability of the software. So, consequence of all the failures need to be understood at the subsystem level itself. So, whenever we are doing a subsystem, we may have to appropriately test, and in case of there seeming to be an error, we will also point those. Thank you.